So for this question here, it's asking for you to find the common ratio. So they want you to remember, if you think about your general form of your sequence, first term, second term, and third term, the first term we generally call it A. That's the first term. Then to find the second term, we multiply the first term by the common ratio R. And then the third term, we multiply the second term by the common ratio R again, so we end up with AR squared. So for our question, we don't actually have the first term, but we have the second term, 192, and the third term, 144. So to find the common ratio, I can actually take the third term and divide it by the second term, because we multiply each term by the common ratio. So here, AR squared divided by AR, which would give me here the common ratio of 144 over 192. So they cancel out, so I'm left with just the ratio. So the ratio, I can simplify it down to 3/4, and that would be the common ratio between them. So now, if we look at part B, it's asking me to find the first term. So using a similar method to part A, I can divide, but I'm going to be taking the second term and dividing it by my common ratio in order to find the first term. So in this case, I'm going to be doing 192 divided by the common ratio that I've just found, which is 3/4. Pop that into calculator, and I should end up with an answer of 256. So now what we're going to look at is part C. So if we have a look at this one, it's asking for us to it's dealing with the sum. So it wants us to recall the fact that the sum of all terms in a series can be found using this formula. So I'm going to substitute in all the information that I have right now. And so the sum is 1000. The first term is 256. My ratio is 3/4. I don't have n yet, so I'm going to leave it as it is. And substituting in the rest of this. Now, it's not an equal sign here because it's looking for the smallest value for when it exceeds 1000. So actually, this is going to be an inequality, and it wants my right-hand side to be greater than my left-hand side, so it should look like this. Okay, now I'm going to simplify to make this a little bit tidier. So this becomes 1/4, and it's a fraction. I don't want it, so I'm going to multiply both sides by 1/4. So I know 1000 times 1/4 is 250. This is just left with the numerator. And then I don't want the 256, so I'm going to divide by that as well. So I'm now left with 256 divided by 250 divided by 256 can be simplified down to 125 over 128. So now this looks a little bit tidy here. I will be isolating for my n, but at the moment it's a negative term, so I don't really want that. So I'm going to manipulate this around so it becomes positive. So I actually end up with 3/4 to the power of n is less than 1 minus 125 over 128. Again, a bit of simplifying. So I end up with 3 over 128. Now, because what I'm isolating is actually an exponent, I need to take logs for both sides. So I end up with log 3/4 to the power of n is less than log 3 over 128. So now, remembering your log rules, the exponent in a log actually becomes the coefficient at the front. So I can take it to the front here. And then once you see that, I can actually divide both sides by log 3/4. Now, when I actually divide by log 3/4, what you have to know is that a log 3/4 is negative. So because you're dividing by negative, don't forget the sign for your inequality is going to flip. So I actually end up with n is greater than log 3 over 128 over log 3/4. So if I pop that all into my calculator, I should end up with n is greater than 13.1 0.047142. Now, I'm not finished yet because it's asking for the smallest possible value for n, which actually makes my series, my sum of the series, exceed 1,000. So the smallest possible value you can have would have to be n is equal to 14.